Now, if you're thumbing through your 6162 notes, noticing how much is left, you're probably feeling really bad for me and what time I'm going to get home tonight. Don't feel so bad. I should not have bothered copying off page 5 and 6 because we're not going to worry about it. It is non-linear systems, and while at some point in trig those will be important, we will learn what we need to do at that point. So we're just not going to sweat it right now. So let's go on with this example. Find the quadratic function passing through these points. But you didn't know you could use a system of equations for that. In fact, there's a whole project I have on this topic we could do if we wanted to and if we had time. But I don't think this year is the year. So let's go ahead and proceed with how to accomplish this. So now a quadratic function is in the form ax squared plus by plus c equals 0. That's what we're going to use. So this should make sense. I messed something up. Do you guys see what I messed up? It's a quadratic function. It shouldn't have two different variables, just one variable, right? So one variable, oh, and it also doesn't equal 0. I'm going to start over. Well, no, I'm not going to start over. It's just going to equal y. So here's our function. Y equals our quadratic function, right? Makes sense? Perfect. All right, so we have 3 points, and we have an x and a y. And we have x's and y's all over here, right? 3 sets of them. So we need to find coefficients a, b, and c. That's 3 unknowns. So we can create 3 equations using the 3 sets of points. Let's do this. Sounds exciting, doesn't it? So for our first set of points, x equals 1 and y equals 6, we're just going to plug in 1 and 6. So 1 here and here for those x's, and 6 here for the y. Let's look at our next point. So a times negative 1 this time. And that equals 10. Then our last one is 2. Plug in our x value of 2. And that resulting y value is 13. That gives us the following system of equations. A plus b plus c equals 6. Well, what happened to the ugly square? That was the x value we plugged in, and it's gone. We now just have a linear 3-variable equation. Let's find another one. 1 squared, negative 1 squared is 1. And then our last one here is 4a plus 2b plus c equals 13. Voila, we have a system of 3 equations and 3 unknowns. We solve for a, b, and c, and we know our quadratic equation, our quadratic function here, right? Okay, let's go ahead and add those together. Looks like it's going to be an easy way to get rid of b. I like that idea. So I'm not even going to rewrite them. If that's okay with you, I'm going to add them together. I get 2a, b's cancel out. I get 2c, add our 6 and 10, we get 16. Awesome. So now I want to get rid of b again. So this time I'm going to multiply by 2 and do this. So 2 times a, 2a plus 4 is 6. And 2 times negative b, negative 2b plus 2b is 0b. And 2 times c is 2, c plus c is 3c. And then we have 2 times... Alright, so times 10 is 20. I realized there was kind of a weird hiccupy gap in my video because the custodian came in and I paused for a second. So 2 times 10 is 20, and then 20 plus 13 is 33. I can do this in my head. I think I got it. 2a plus 4 is 6a, 2, that cancels. 2 times c is 3, and then 20 plus 13, 33. Yep, I'm good. Now I have a system of these. So that gives me, I'm just going to go back to blank. Oh, I don't want to just add these together. That's not going to get rid of anything. I want to get rid of something. So maybe I should multiply this one by negative 3. right? Sound good? I don't think I should have thrown this little line in here. Okay, so I'm going to multiply that first equation by -3, and I'm going to write it down. -6a minus 6c equals -48. I know these get kind of confusing. We're actually going to learn a way to organize all of this mess into a better format called a matrix, and basically do the same thing when we get to section 6.3. It will be an adventure. It's honestly my favorite stuff that I ever learned in algebra. And then I was so excited to teach it to people and realized that no one likes it as much as I do. It's like puzzles. You know, we're solving these intricate puzzles, and it's so exciting to get to the end solution, to put in that last piece after all the work. Just the patterns that come together. Okay, I'm going off again. So we have C, and we're going to have to plug that in somewhere so we can find A, perhaps. So let's go ahead and plug that maybe in here. So then we would have 6a plus 3 times 5 equals 33. Actually, it would have been much easier if I just plugged it into the... No, not the original. Okay, I'm getting lost. I really need to go home. You guys are going to be so amused when you watch this, which is good, because if you're watching it over the break, then, you know, you ought to be amused, because Thanksgiving is about being thankful for things, like for crazy teachers. I hope you're grateful for your crazy teacher, because I work hard for you. Okay, 18 divided by 6 is 3, and I don't just do it for the money. I mean, it's a teacher pay, you know? Teachers are not in it for the money. They are in it for you, because we care about you. So I got A equals 3, and now my last job is to find B, so now I can plug both of these into one of these. I'm going to pick this one here, so lots of arrows to confuse us. So I'm going to put 3 in for A, and I don't know what B is yet, and I'm putting 5 in for C, and then that all equals 6, so I get 8, and I subtract my 8, and B equals -2. Whew! I am ready to finish out my quadratic function. So y equals a x squared minus b x plus c. There it is, quadratic function going through those 3 points. Pretty cool. I had one last thing to tell you, and then I just realized that I already told you, and that is you don't need to do pages 5 and 6. This is the